So our last summary is about strategy and technology-based industries. Please watch the video on Kodak, and it's a good example for disruptive innovation. It's an innovation that creates a new market or enters at the bottom of an existing market by providing a different set of values, which ultimately overtakes incumbents. Kodak is a good example. They invented digital photography. However, they were afraid that it will cannibalize their film business. And therefore, they actually did not produce good digital cameras. And when the revolution hit the entire industry, it was too late for them and they went bankrupt. So that's a good example of disruptive innovation or disruptive technology. Like even if you had the best film factory on the planet, it's not relevant anymore. Okay, so it's actually useless because digital photography does not need films. Okay, it has a different set of values. So let's talk about a first mover advantage. So many people claim that there is a first mover advantage. The only problem is that when people go and research the issue, they find that it's usually the followers, the second movers, that make more money. The main question is why? Well, you have to remember that followers in many cases learn from the mistakes of the innovator, of the first mover. And in many cases, it is the first mover that spend a lot of money, a lot of energy on convincing the market that they need the new technology. And then the second mover comes and actually earn from that effort. So there is an advantage when you enter, if you enter the market, once the market potential and direction of technology is clearer. And there were very few cases where the leaders, actually, the first movers, dominated, but it's because of patents or they use the lead time, the time it takes others to imitate them to build their brand, reputation, and so on. So there is no generic answer. Should you be first or second? It depends on many things. First of all, there is sources and capabilities that you have. Well, if you have the required resources and capabilities like a factory and so on, maybe it's better to be first. The extent to which innovation can be protected by property rights or lead time. Well, if you have a good patent and you know you can, it defends your innovation, it protects it, then maybe it's better to be first. The more important complementary resources, the greater the cost and risk of pioneering. In other words, if the first mover depend on complementary resources that actually belong to someone else, then the first mover will have to incur the costs. Will have to invest a lot in preparing or arranging the market for that product. For example, if a producer of electric car will have to take care for all those charging stations, then it is the first one, the first mover that will have to bury all those costs and all that effort. Second movers will enjoy that effort, okay? And the potential to establish a standard. We have discussed previously format wars and standard wars. Of course, if you believe that your product will become the ruling standard, then of course it makes sense to be the first. So followers, in many cases, when they really succeed is when when there is a transition of a new product from niche market to mass market. For example, you can say that the PC, the IBM PC, I mean, there were no personal computers. There were personal computers, but basically computers at the time were huge machines that were bought by governments and universities and large corporations and armies. And somebody came with the idea of having a personal computer. Okay? So that was a big success. And it was taking a product from a niche market and bringing it to the mass market. The same with the video technology. Studios in Hollywood had video technology, but then some companies decided to bring it to the domestic market. Okay, so from the niche market of the Hollywood studios to the home market. That was also a big commercial success. In some cases, active waiting. That means that you assemble the resource and capabilities you need to compete in the market, but you wait, okay, until you feel the market is ready for it. I've seen it in Denmark, a company called Three, a provider of mobile services. They convinced the Danes that they need 3G on their mobile. At the same time, the larger company, TDC, had a network, a 3G network, but they didn't open it. They let Three spend millions on advertising and educating the market. And only when they felt that the time is ready, they opened their 3G network. So sometimes it makes sense to wait, but be active. In other words, why active? Because you build the resources and capabilities you need. You just wait for the right moment in time to release or to launch your product or service. So let's talk about innovation. What's an invention? That's a creation of new product or process through the development of new knowledge or new combinations of existing knowledge. That's invention, okay? Think about the invention of the wheel, like 5,000 years ago in many different places on the planet. Innovation is the initial commercialization of inventions. In other words, somebody sells it on the market. Somebody puts it in a product, creates a product from this invention and offers it for sale. So the first car in 1885, that was an innovation, and it embodied a number of inventions like the engine, the wheel, and so on. And actually, many inventions never progress into innovation. For example, there are a lot of unused patents. I mean, it could be more than 90% of patents that companies register, but will never be used. So that's the process from basic knowledge to innovation. Sorry, from basic knowledge to invention to innovation to diffusion on both supply side and demand side. Think about, I mean, humans had this basic knowledge that it's easier to move large objects on something round, let's say on a piece of wood that is round. And then that's the basic knowledge. And then somebody invented the wheel. And then in 1885, there was an innovation, the car. And then there was a diffusion on the supply side. More and more companies adopted that innovation. They imitated this innovation because they wanted to make money. Okay? So that's the supply side, the side of the producers. On the demand side, the side of the users, more and more people adopted the new innovation. So actually knowledge develops or evolves on both sides of the market, supply and demand. Well, it takes time also between knowledge creation and innovation, like the jet engine was patented in 1930, but actually somebody started selling it as a commercial jet airliner. I don't refer here to military aircraft. As a commercial jet airliner, somebody started using it only 27 years later. Same with the MP3. It takes time. It can be many years between innovation, between knowledge creation and innovation. Sadly, innovation is no guarantee for fame and fortune. In many cases, actually, it's not the innovator that makes the big money or that has the biggest commercial success. It's actually other people. So what does it depend on? So this is our cake. And we'll discuss appropriation of value, or how much of the value will remain in the pocket of the innovator. Well, in many cases, it's not a lot, because first of all, customers gain or keep much of the value. Usually they're willing to pay for a new product much more than they paid. Think about you and your laptop or your smartphone. Suppliers, of course, will make money as well, and imitators and followers will also make a lot of money. So usually the innovator will get also only a small piece of that cake. The PC is a good example. The first company, somewhere in the mid-1970s, didn't do very well. It was the second generation, the imitators, that made more money. The suppliers, Intel and Microsoft, actually got the biggest chunk of the cake. And that's because of the monopoly position in the market. We have discussed it before in this course. And you can argue that most value is appropriated by the customers. People would be willing, if they had no other choice, to pay for their laptop even 10,000 shekels, but they paid only 3. So most value remained in their pocket. So let's discuss 4 critical factors that determine how much of the value an innovator can actually earn or appropriate. So it depends on property rights, tacitness, and complexity of the technology, lead time, and complementary resources. So property rights, well, if you have a patent, that's a good start. That would allow you to keep more of the value. If you have a trademark, you have a brand that people recognize and are willing to pay for. Of course, if you have copyrights, that's usually when you create movies or songs or software. And of course, if you have trade secrets like recipes and formula and so on. So if you can actually protect your intellectual property rights, generally speaking, you will earn more of your innovation. Tacitness and complexity, it basically means that if it's a secret, then it will be more difficult at the end to imitate. And that means that you'll earn more money. Of course, at the end, all technologies can be imitated one way or another, but the more secretive it is, the more complex it is, generally speaking, the longer it will take to imitate your innovation. Of course, there will be a lead time if it's tacit, if it's top secret. There will be a lead time, the time that it takes for others to actually imitate it. Complementary resources. That's the resources and capabilities that are needed to finance, produce, and market the innovator. Okay, and the more you depend on those, usually the less you will earn from your innovation. So there is a relative power. Are they specialized or unspecialized? In other words, if those resources and capabilities that are owned by other people are specialized, you ask them to adjust those to your needs, then of course you'll have to share with them much more of the value. If they have a factory and they have to adjust their factory for your innovation, they will demand a larger share of the value, okay? But if they are generic, then of course you'll earn more from your innovation. A good example is fuel cells. The people that develop that technology actually depend on car manufacturers to change their production lines. And in that case, they'll have to let them have a higher share of the value. In other words, of the money. Okay, so if you need to protect your innovation, which mechanism are effective? So that's a study that was actually, it's basically questionnaires. They ask managers about product innovation and process innovation and what helped them defend more their innovation. Is it secrecy? Is it patents? Is it lead time, the time it takes competitors to imitate you? Or is it complementary resources and capabilities in sales and services or in manufacturing? So what we see here basically is that patents have been more effective in protecting product innovation in drugs and medical equipment than in food or electronic components. And the question is why? Okay, how come patents are better at protecting product innovation in drugs and medical equipment than in food, for example? So think about it for a few seconds. It's an important one. Well, basically, drugs relate to a specific formula. It is very specific. If you want to produce the same drug, you'll have to use the same formula. In other words, it will be easier to protect that patent or that these intellectual property rights in court, for example. You can sue people who would use your formula without paying for you royalties or buying from you a license. With food, it's different. I mean, food is a recipe and it's easy to change. I mean, you can add a bit more salt, less pepper, and say that your recipe is different. That's why when you talk about food, it makes more sense to use secrecy as a defense mechanism. Another question is with regards to process innovation and product innovation. So the table shows that patents are more effective in protecting product innovation than process innovation. And actually, the idea is quite similar. New processes are incremental improvements, okay? Or reconfiguration of existing processes. In other words, you can change something small in your process and argue that you developed something different. On the other hand, with products, they are much more specific, and therefore it is easier to defend, to protect your intellectual property rights for something that is specific. So if you developed a new process, maybe you should consider alternative mechanisms like secrecy and lead time, or if you have some special manufacturing capabilities that others don't have. The industry life cycle, that's another model that helps us understand strategy in technology-based industries or in knowledge-intensive industries. So the model basically is very simple. Industries they have an introduction phase, they have a growth phase, maturity phase, and decline, okay? Of course, this model is mainly relates to technology products and services. Think about appliances for music playing, okay? So we had an industry of gramophones and patiphones and cassette players and vinyl records before the cassettes and CDs and MP3. So there have been many industries that actually were born. They had an introduction phase, they had a growth phase, they had a maturity phase, and then they declined. We don't have compact discs or vinyl records or cassettes anymore, tape cassettes at home anymore. And all those industries basically disappeared. So what drives that evolution? So it's the demand growth and its knowledge. We'll discuss these two elements. So if you look at demand growth in the introduction phase, the first phase, we have a new technology, and it's usually a small scale of production. The product is usually very expensive. Think about the first CD player, for example. So the people who buy it have too much money usually, and they actually like innovations and so on. If the product is a success, the industry will have a growth phase where actually the product will be technically better, it will be more efficient, and the mass market will open up because prices will start going down. And in the maturity phase already, everybody has it. So people who buy a new one just to upgrade or replace the existing product. And if you look at the decline, that's when some superior product appears in the market. If we talk about knowledge, in the beginning, usually there is a lot of innovation, and we don't know how the product will finally look like, okay? Think about the first smartphones. There was different configurations, different architectures of smartphones. And at the end, since the iPhone, well, all smartphones look the same. They have the same architecture. So in the beginning, there is a lot of different shapes, different configurations, different architectures. The same happened in the PC. It had some producers built PCs that could connect to your television at home. Others had a screen that was dedicated to the PC. So there were many different configurations or architectures of a PC, but since the IBM PC, all of them look the same. So that's basically the dominant design. So after the period of introduction, there is a product architecture that most producers and most customers adopt. We call it the dominant design. The iPhone is a dominant design because most producers and most users prefer that architecture, that structure, that product. There's been many dominant designs in many industries, from typewriters to cameras, even in business models. You can say that the McDonald's business model that came in the 1950s actually is a dominant design for the fast food industry. And of course, laptops and smartphones. So the question is, what forces actually caused this product architecture to become the dominant? If you think about the IBM PC, how come it was this architecture that was chosen? Why did others imitate it? And has it evolved or been displaced? So basically speaking, IBM was an early mover. It wasn't the first, but it was early in the market. It has a lot of resources, like financial resources, technology, reputation, brand, and so on. And that allowed them actually to, that actually made other companies choose or imitate that design. And the design itself was good. Maybe it wasn't perfect, but for most people, it did what they expected a PC to do. So why did others imitated it? Well, it was efficient, it works, and it's more economical for the entire industry to have one platform. In other words, if you are a producer of printers or computer screens, you prefer that there would be one platform in the market than a few. Because if there are a few different PC configurations, you'll have to adjust your printer to each and every one of them. And having one design allows specialized suppliers to emerge, okay? So it's more efficient for all those peripheral equipment developers and producers. It's more efficient to software development that there is one main platform. So has it evolved or displaced? It actually evolved. And dominant designs usually remain for many years. They are usually not displaced. Of course, they are upgraded, they evolve, but they are not displaced. They remain similar for many, many years. So we said that in the beginning, there is a period with a lot of innovation, a lot of different product architectures, and then there is a dominant design where that most of the industry agree that that would be the best architecture, and then we move from product innovation to process innovation. Okay, so that's how it looks like basically. The vertical axis is the rate of innovation, and the horizontal is the time. So in the beginning, there's a lot of product innovation, a lot of features. Okay, companies innovate new features for the product or the product itself. But after there is a dominant design, there is the rate of innovation changes, or the type of innovation changes. We actually shift to process innovation. So the innovation is more to do with how we produce the product. So production becomes more efficient, or how we sell it, or the distribution and logistic methods for selling the product. So let's talk about the smartphone. What do you think then? Does the model fit? Well, generally speaking, the model works just fine with the smartphone, okay? So we had an introduction phase, and then there was a huge growth. I mean, and nowadays we're in the maturity phase. Yes, people buy smartphones, but it's just to upgrade the one they have already. So that's the phase where people actually get rid of the old one to get a new one. That's the maturity phase. And if the model is right, one day the entire industry will disappear and there will be something better. We don't know yet. But so far, the model works well with smartphones. Okay, so how general is the life cycle pattern? Well, the model works fine, generally speaking, but you have to remember that the duration phase, for example, varies greatly across industries. In the car industry, it took 25 years until we had a dominant design. In the PC, 4 years. Generally speaking, life cycles become more compressed, but you have to remember that the model is very, very general. You cannot conclude that if in the PC market it took 4 years before there was a dominant design, that the same will happen with a new technology, okay? A pattern of evolution is also, can be different. So you have to remember that basic necessities will never enter a decline phase, okay? So construction industry or food processing industries and so on, we don't expect them to decline. The model is more useful when you talk about high-tech products, about smartphones, about MP3 players, patiphones, technology-based products. Also, an industry is likely to be different, is likely to be at different stages of its life cycle in different countries. So the car industry in the US and in the EU is actually probably declining, but in India and China, it's having a growth phase. And that's it. That's our last summary. I hope it was useful for you, and I hope you'll succeed in the exam. Take care.